This video is going to talk about factor analysis more at like a conceptual level, just talking about what it is, and also in the context of surveys, as far as like questionnaires and stuff. But it has more applications, and also this video isn't really going to talk about how to carry it out, but it's a good place to start if you don't know what factor analysis is and you're interested in knowing what it is, basically. So the basis of what it's trying to do is explain the variation in a bunch of variables in terms of a smaller number. So like let's just say we have a linear regression or something where we have like 40 variables. Some of those variables might be related, and we might be able to describe those 40 variables in terms of like 5 groups. And it relies on this underlying assumption that like some of these highly correlated items, and item is one of those terms from the scale video. Again, this is kind of in the context of scales. An item is like a question on a survey. Factor analysis relies on this like underlying assumption that some of these questions on a survey are highly correlated and are brought together by like some underlying idea or symptom, basically. So in the scale video, I used like Mario as kind of an example of like a survey is looking at like a latent construct. So like you might have a survey on like depression, and depression is something that is kind of fuzzy and hard to ask one question, like how depressed are you? But it is composed of several symptoms that you can ask about individually. And similarly, this latent construct that we perceive as Mario is made up of like 100 little Lego blocks. But when organized together in a certain way, we perceive it as this latent construct that is Mario. But instead of looking at it like a bunch of little blocks, like how a survey would typically look at it without factor analysis, we don't need to just look at Mario as like 100 independent blocks. We can group them in a couple ways. Like here I'm deciding to group them based on color. And when we do that, we can describe Mario in terms of not 100 blocks, but we can describe him in terms of like overalls, shirt, hat, and if we kept going, just other things. And that's kind of what we're doing with factor analysis. Instead of just 100 little blocks, we're describing them in terms of a smaller number of things. So I'm just going to keep going with this depression example where that's our latent variable, our domain, and our measured items are things like symptoms of depression like fatigue, over and under eating, sleep issues, self-esteem issues, loss of interest, and hopelessness. The way a traditional survey works is each of these are considered equal predictors of depression and contribute to your depression score. Where like each of these fatigue, eating, and sleeping questions would basically be like how often have you experienced this in the last week, 0, 1, 2, and basically that they all contribute equally to this overall score of how depressed you are. But some of these actually might be related. The 3 on the left share something in common, and the 3 on the right share something in common. And basically, I would say that the 3 on the left are very somatic, they're very physical symptoms, while the 3 on the right are more psychological symptoms. And it would be nice if we could describe our predictors of depression in terms of 2 variables instead of 6, and that's what factor analysis allows, basically. So in the interest of space and simplicity, I'm just going to use the blue half. I'm just going to ignore the orange half for now. So if we have these 3 questions that are asking about these somatic symptoms, and they're each a score from 1 to 3, and this person put 2 for fatigue, 1 for appetite, and 3 for sleep, we can basically come up with a raw score where each of these is considered equally. Basically, they are all equally contributing to the overall score. But if we're describing them in terms of an underlying variable, somatic symptoms, we can parse them out and weight them based on how related they are to this latent construct. And that permits us to do this thing called loadings, which a loading is the extent to which something is related to a latent factor. So here we can see that, like I just made these numbers up, but we can see that like the thing of these 3 that is most related to like the somatic symptoms of depression is overeating, while trouble sleeping is maybe like a lower, less important, quote, predictor of the somatic symptoms of depression. And yeah, that's kind of abstract, but it'll become more clear. There's other ways of looking at it that people have tried, such as looking at it as like a linear equation. Okay, yeah, I wasn't ready to talk about that yet. So yeah, this would add to 6, but we can have a weighted score where each of these loadings is basically used to weight each of these things, fatigue, appetite, and sleep, based on how important we think it is. So here we think that sleep isn't necessarily important. So even though it has a score of 3, we would do these weighted scores where we're multiplying the raw score by the loading. Basically, even though sleep had a score of 3, we gave it a low loading because although someone scored it high, we don't think it's as important as the other variables in predicting depression. So we basically weight it lower. So instead of it being 3, much more than like the other ones, it's 1.5 now, which is only like a little bit more than 1.2, and yeah, basically you can see how 2 and 3 are further apart than 1.2 and 1.5. So it shows that basically when we weight sleep downwards, we see that like fatigue and sleep are contributing similar amounts to this depression score, and that's basically how you come up with the loadings. The loadings will be basically derived from like a statistical program, and what's cool sometimes about like exploratory factor analysis is you don't even tell the program how many factors you think there are. You basically send it out looking for factors, and it'll basically take your data, like your 20 questions or whatever, and say like, I think these 20 questions can be described in terms of 4 things, and the computer doesn't know what those things are. That's up to you to look at how things are grouped and say like, what are these latent constructs? And it's pretty good at that as far as I know, and hopefully I'll do a video on how to conduct factor analysis, but this is just about what it is. Something I thought was kind of cool is you can look at this as like a linear equation where somatic symptoms can be described in terms of fatigue, diet, and sleep, and each of these has a coefficient, just like a linear equation. You'll notice there's no intercept, and I guess in this case it just is starting at the origin, which aligns with this picture I found. This picture is going to freak you out at first, but I think it's really cool. It's a way to like kind of visually and geometrically represent what factor analysis is doing. The picture has 2 factors, so the picture has basically 2 items or whatever factors. So like I'm going to show just basically what that would look like, where we have the somatic symptom as this like vector that is coming out, that is composed of many things that are making it go in a certain direction, if that makes sense. So ZA here, the red line, is our resulting vector of our like somatic symptom score. And the idea is that each of these individual components, so fatigue and diet, I got rid of the third one just because the picture had 2, are 2 things that also kind of describe its direction in space, and the degree to which they both offset it from the origin is the loading, so that's the green here, and nothing's measured perfectly, so it gets pushed up again into the 3rd dimension with residual error. That might have freaked you out, and if you already kind of understood and that made things muddier, just forget about that. I just thought that was kind of cool. So in reality, you usually have multiple factors here, where like we have somatic symptoms and psychological symptoms, and each of them would have their associated loadings, and we could put them all together into our like questionnaire, where it has like these like 6 items, and we could get a weighted score that is different than our raw score. And the reason it's different is that the raw score weighted every question equally, while the weighted score decided that some questions were more important to this latent construct than others. And there's a lot of reasons to want to do factor analysis. Some of them are to better understand the latent construct, so find things like those somatic symptoms versus psychological symptoms. It kind of simplifies the construct of depression. It can be good for weighting questions, like I just described, where some questions might be more important than others in describing depression. It can also be useful in item reduction, and that's, again, in the context of scales, where your scale or questionnaire might have like 30 questions and you want to get it down to 20. it can be helpful where like some things might have really low loadings here where like again, I made up these numbers, but low self-esteem here has a loading of like 0.1. It's not predicting psychological symptoms and hence depression very well, so we might eliminate it because it's going to be weighted very low anyway. And it also is sometimes something people don't want. Double loadings where trouble sleeping is related to multiple latent constructs, like it's maybe related to psychological and somatic symptoms. And some people, just to simplify things, eliminate cross loadings. I don't know nearly enough about factor analysis to say whether that's okay. But yeah, that's basically factor analysis from the viewpoint of an epidemiologist. I think in an economic or sociological setting, there might be very different thoughts on factor analysis. But that's just what I learned basically.